Hello everyone and welcome to day 3, which is on an introduction to proofs. So first, what is a proof? A proof is a line of logic with statements and reasons. Basically, you are showing one thing is true using statements and reasons, and making like a line of thinking given to prove something is true. Cool. What makes up a proof? Well, we already kind of answered that. We have statements and reasons. So statements are like a fact or something that is leading you down that line of logic, and the reason is the reasoning behind we know that that statement is true. What can be used for the reasons? Well, we can use definitions, theorems, or math facts. If you're just simplifying 2 plus 2, we know that that's 4. The reason for that would just be it's a math fact. 2 plus 2 is 4. So in math, we make a lot of assumptions. So there's some things that we can assume are true and some things that we cannot assume are true. So some things that we can assume that lines are straight. We can assume that. To be honest, there's not a lot of things that you can assume in proofs, but there are a lot of things that you can't assume. For example, you cannot assume right angles. You have to prove those. You can't assume parallel lines. You can assume that the lines are straight, but you can't assume that they're parallel. You cannot assume congruent angles. You can't say that these two angles look the same, so they probably are the same. Not a good assume. So we could go on and on in that list of things that you can't assume, but let's just get on to some examples. So number 1, we are given some information. We're told B is the midpoint of AB or of AC. So here's AC. Boop. B is the midpoint. So our first statement always is the given. B is the midpoint of AC. And our reason for that is it's given. That's the same first step as all of our other proofs that we've been doing on the other days. Now we're trying to prove that AB is congruent to BC. So I'm going to write AB is congruent to BC. Now the tricky part is my reason for knowing that's true. Well, I know that midpoints cut things in half. That's just what midpoints do, which means that AB has to be congruent to BC because midpoints are the middle. So that's exactly my reason. But the way I'm going to word it is I'm going to say it's by the definition of midpoint. It's what a midpoint does. I already know that that's true based on just it being a midpoint. So that's my reason. For number 2, again, first step, always write down your given. So in this one, we're told BD bisects angle ABC. And that's our given again. We are trying to prove that angle ABD is congruent to angle DBC. Now, a bisector, we're told BD bisects this whole angle. A bisector cuts angles in half or cuts lines in half. So we know that just by that being a bisector of that angle, it's cut the angle in half. So my reason is by definition of bisector. It's what a bisector is, it's what it does. So we already know that to be true. Okay, number 3, we got our given, told the measure of angle 1 is equal to, well, not congruent, equal to 55 degrees. That is my given. So I've got angle 1 and it's 55 degrees. Well, I'm going to try to prove that angle 3, the measure of angle 3, is also 55 degrees. So I need that middle step in the reason, and I also need the last reason. So I've got angle 1 is 55. I'm going to look for a relationship between angle 1 and angle 3 that I could put in the middle there. Well, angle 1 and angle 3 are vertical angles. Remember, vertical angles are congruent to each other. So I can say that angle 1 is congruent to angle 3 by vertical angles. And vertical angles are congruent. Now that I know that those two angles are congruent, I can confidently say that the measure of angle 3 has to also be 55 degrees because that's what congruent means. So my reason for knowing that the angle 3 is 55 would be the definition of congruence. That's what congruent means. They're the same measure. So if angle 1 is 55, then angle 3 is 55. Okay, so now for some other properties. First, the reflexive property. This property says that a number is equal to itself. So A is equal to itself. That's it. That's the reflexive property. The symmetric property says if you have A is equal to B, so two numbers that are equal or two variables that are equal, then you can also write it as B is equal to A. Same thing both ways. The transitive property says that if A is equal to B and B is equal to C, then A is equal to C. Basically, if A is equal to a number and C is also equal to that number, then A and C are equal because they're both equal to the same thing. And last property is the substitution property. The substitution property says if A is equal to B, then B can replace A. So we can use that here. So say A is equal to B. If we have an equation that says like A plus 5 is equal to 0, I can also replace A with B and just write a B instead. So B plus 5 equals 0, and that's the same thing, basically, because since A and B are equal, I can interchange them back and forth and not change the value of the equation. Okay, now we got a bunch of mini proofs to do. So mini proofs are just, it gives you a statement with a given, and it gives you another statement that you're trying to prove, and you just have to fill in the reason for how we know that that's true. So this first one, we know angle A is 55, that's our given. So we're trying to say that angle A is acute. How do we know that it's acute? Well, acute means that an angle is less than 90 degrees. 55 is less than 90 degrees, so we know it's acute. So our reason for that is definition of acute angles. Basically, since that's the definition of what an acute angle is, less than 90 degrees, we automatically know that angle A is acute because it fits that definition. So remember, definitions and theorems can all be used as reasons. Next one here, I have angle A is equal to the measure of angle B. So measure of angle A is equal to the measure of angle B. Remember that the M here, that means measure. So we're talking about their actual degree measure. That's our given. So then in my next statement, I have angle A is congruent to angle B. So how did I get from step 1 to step 2? Well, if I know that the measures are equal, then I can say that they're congruent, because congruent means that their measures are equal. So that would be a definition of congruent. So on this one, we have angle 1 and angle 2 are vertical angles. That is our given. So in our next statement, we have angle 1 is congruent to angle 2. And that is by the reason that vertical angles are congruent. That's a vertical angle theorem that we learned about way back when. Okay, next one. We have this diagram here that is our given. It says ST, TU, SU line. Here, in our second statement, we have SU is equal to ST plus TU. So our reason for that is going to be the segment addition postulate. The segment addition postulate, again, from way back when, says if you have two line segments like ST and TU, if you add them together, you can get the whole thing, which is exactly what happened in this case. We added two line segments together and we got the whole thing. Okay, we are almost done. Here we have angle ABC is congruent to angle DEF. And in the next statement, we have angle DEF is congruent to angle ABC. Now, if you remember, that is called the symmetric property. The symmetric property said if A is equal to B, then B is equal to A. It works the same both directions. If you switch it around, it's still the same thing, but it's called the symmetric property to switch it around. So on the last one, we have two givens, technically. We have TU is equal to XY, and we have AB is equal to TU. And in the last statement, we have AB is equal to XY. So here you see TU and TU twice. Basically, that just means that since these line segments, XY and AB, are both equal to TU, then they have to be equal to each other. If you remember, that is called the transitive property. It says if A is equal to B and B is equal to C, then A is equal to C, because they're both equal to B. Okay, and that's it for day 3, so we'll see you all back for day 4. Bye!